All right, welcome to IPPM. This is the last session. I think we'll probably wait a couple minutes before starting to let some other people show up. But I guess if you are remote, maybe if someone can give a signal of if you can hear the audio just fine. All right, we have confirmation.
Yeah, 1 minute. Yep. Vienna on the slides. Okay. We're not in Vienna, even though the slide says so.
No. Okay, can I redo it quickly enough? Does it matter?
So in case you're wondering, we're still in Philadelphia.
Just a quick audio check before we get going. It's Al.
Works fine. We hear you.
Thank you.
So congratulations, everyone. You've made it to the last session of the week. And this is IPPM. And we'll get started very briefly here. I can take the time to remind you all, if you're in the room, that you should please wear your masks, except for when you're up talking, then you have the opportunity to take your mask off. Otherwise, we would like you to keep the masks on. And please use an FFP2, KN95 or equivalent mask as well. Okay, we have now been teleported to Philadelphia, so let's continue. So yeah, welcome everyone. This is IPPM, last session of the week. Hope you're still awake and fresh. And yeah, let's get on with it. I hope you're all familiar with this slide. If you're not, you should really try to read it by now. It's important for whatever you try to say and what you contribute with there. So yeah. Meeting management. We're running this as a hybrid meeting, so you can join MeetEcho on this link here. If you are on site and you want to join the queue, please do so via MeetEcho, either using the on-site tool that you can have on your phone or via the MeetEcho session on your laptop. We'll be using MeetEcho for sharing slides. All the slides are loaded here. We can advance the slides for you, or you can request permission to advance the slides yourself. Notes can be found here, and we would like to have somebody volunteer to take notes for this session. It's the last session of the week. Oh, thank you very much. Do we have somebody who can take the role of jabber scribing as well? Just relaying stuff from the chat.
I can watch.
Oh, okay, perfect, perfect. All good. So, document status. We have a couple of documents that are owned by the IESG right now. There's a bunch of reviews of IOM flags, direct export, RFC 8321 bis, RFC 8889 bis. Lots of good reviews, some revised IDs flying around, and it looks like we're making good progress with this. We also have IOM conf state and IPv6 options that have been handed over to our AD. And we have an ongoing, or we just had a working group last call on explicit flow measurements. And I see we have Martin Duke in the queue.
You see, I'm still the delegate from Vienna. That's cool. Yeah, so conf state, that's on me. I've sat on that for like almost a month. I'll get to that like next week. IPv6 options, to be clear, is with the, well, I mean, I have possession of it, but the action item is on the authors. Just to reiterate that in case they're listening and don't realize that. And 8321 and 8889 will probably be a while before it gets through ISG. I think we have to do another big scrub on the experimental language in there, kind of loosey-goosey. You can try this or that stuff. And frankly, input and help would be useful there. If people aren't so inclined. Thanks.
Thank you. Right, next slide, please. So we have a quite packed agenda today, lots of drafts. So we will be focusing mainly on drafts that we are working on that are adopted by the working group. So we'll be starting with presentation of IOM data integrity and deployment. It will be presented together. And then we have the IOM YANG and Stamp YANG, Stamp SRPM. Then we will have a bit longer presentation on the IPM the capacity protocol, followed by a presentation on the explicit flow measurements, which has just been through working group last call. Then we have IPPM responsiveness and encrypted PDM v2. These are the adopted drafts that we'll be focusing on this meeting. Are people fine with this order of presentations? So it seems. And then we have one more presentation. It's about precision availability metrics, which will be presented by Greg. So let's get started.
Hi, everyone. So just a quick update on the IOM integrity draft first. Again. Yeah. So what we made as changes from previous version is pretty light. So we can call the document quite or pretty stable by now. The changes include that we replaced references to draft that became RFCs. So you can find them on the slides. We also rewarded some important parts, and that led to actually merging the decapsulating node and validator roles. And we also included some editorial changes. So basically, you can find the pull request by clicking that link, and you will have each detail that you need. And so a good news is that there is an ongoing implementation effort by the University of Liège in Belgium. So next slide. Thank you. And so we could actually already consider a working group last call maybe, but we feel that we're not in a hurry. So this is my question for you. Should we wait for feedback on the implementation? We should have it by let's say September, and then consider a
thank
working
you.
group as call?
That makes a lot of sense.
Do you know if there's any plan for other implementations so we can test interop with this? I don't know how much that
Right now, this is
matters.
only planned for VPP.
Okay. I think having the one implementation is probably sufficient so we can do the working group last call reviews. It would be fantastic to see other implementations, as we are progressing the document. So I don't know if we can try to rope people into doing hackathon at the next IETF or something like that.
Why not, yeah.
That could be useful.
This is worth mentioning that the implementation is about the integrity of the trace, because this is kind of a corner case in the integrity of IOM. So that's all for the IOM integrity. I don't know if Tal is already available. Should I take the presentation for him? Yeah, because you had a conflict. So quite quick for this one too. Next slide, please. So no change from IETF 112. We published the new version right after Vienna, and basically it only includes references to peer. And so that lets us to consider maybe a working group last call.
Xiaomin?
Hi, Xiaoming from ZTE. I have a comment on this document. I suggest the authors to add one more reference to IOM conf state. As you have seen on the chair slide, that document is now passing working group last call and with our transport AD. So I suggest you to add that reference and add some description on the function of IOM capabilities discovery. Thank you.
Okay, thank you. So again, I'm just a proxy of Tal and other authors of the document, but I'm sure they will consider your remark. Thank you.
Thank you.
For the notes, should we get that down? I think that's the conf state, configuration state document that they want to reference to. Jiamin was asking for a reference from the deployment document to the IOAM conf state.
Good. Thank you.
Okay, can you hear me? This is
Yes.
Tian from Norway. Thank you. And in this presentation, I will report the major changes since the last meeting. And next. We adjust the comments from Andy as the young doctor early review. There are some major minor issues. Firstly, use the derived from or self for the when statement using identities. We followed this suggestion and modified the YAM model. And then use the interface ref data type. Yes, we aligned. And the use of plain string as a list key. To adjust this, we add length 1 to max to disallow empty strings. And to clarify the use of order by user, we checked the list and the usage. There is actually no special user order, so we removed this statement. And is there any mandatory functionalities? We add a description to clarify this. There is no mandatory type of profile in the list, but at least one profile should be added. And then there are several points in the model. The description are very simple. We added more detailed information here and there, especially for the mentioned lines. At last, we cleaned some needs, and that's all. Next. The RFC 9197 is published. This EM model is already aligned, stable, and mature, so we would like to ask for working group last call. Thank you.
Yeah, it seems like a good time to do that. Thank you very much.
More yay.
Okay, hello. Next slide, please. So this is just an give you a quick update. We progressed the work, and as discussed in our previous meeting, so included the coverage of RFC 8972, stamp options extensions. So next slide. So now it's for their operational stamp information. Now it's a config false, so it will be read only. Next slide. And it includes the 8972, including stamp session identifier that may be used for session demultiplexing, as well as extra padding, location TLV, time step information TLV, class of service that allows testing, treatment of different DSCP markings, and one-way both directions, direct measurement loss, access report, follow-up telemetry, so to improve accuracy of timing measurement, in particular in virtual environment, NFV, and authentication for extensions. Next slide. So next we'll continue working, and we'll try to get it ready for the working group last call by the next meeting. Any questions? So please take a look at this document, and please send your comments and questions on the mailing list. Thank you.
Yeah, thank you for this. When we have a new version that we think addresses all of those early comments, that looks like, I think that early review was done quite a long time ago. That was 2018. So I'm wondering if it would make sense. You can just let us know on the list, and then we can kick off another Young Doctors review. Then we'll do last call.
Yeah, we follow by the list of comments that Mahesh provided, and addressing when we feel comfortable, then we'll appreciate your help, and we'll reach out so to have another. Thank you.
Hi everyone, my name is Rakesh Gandhi, and presenting the stamp extension for SR on behalf of the authors listed. Next slide, please. So it's a very brief update on the revision that we posted recently, just to highlight some work in other working groups and the next steps. Next slide. So many thanks to Footer for his help with aligning the draft with RFC 8972 for the flags and the TLVs. So the new flag, we had defined verification flag. It applies to all the stamp TLVs and including the 2 TLVs defined in this draft. So some text edit for that. And there is a notion of symmetric packet size. So this is also added for the 2 TLVs defined in this draft. And this also allows us to transmit the TLV flags back to the sender. So other than these 2 updates, we added experimental values for the TLVs in order to facilitate interrupt testing and implementation. But we also have made a request for early INI allocation as well. There are some few minor editorial changes and we don't have any open issues. So many thanks to everyone who reviewed the document and provided comments as well. And next slide, please. So we do have few companion drafts in other working group. There's one in the spring for the SRPM using a stamp. There's also some for the enhanced SRPM as well as one for the MPLS pseudo wire. Next slide, please. And we are seeking your comments and suggestions at this point, as well as the INI early allocation. Thank you.
Greg, you have comments?
Hi, thank you, Rakesh. And I just wanted to, FYI, we talked with Rakesh and Footer about some other methods, and we started work on document IP UDP encapsulation of stamp in MPLS and using LSP ping to bootstrap stamp test session along with their controlling the path for reflected test packets. So aiming this work for MPLS working group, but appreciate your reviews and comments to MPLS and IPPM working groups. Thank you.
Okay. Yeah, thanks, Greg. Yeah, we had a good meeting and there were some good discussions, and we'll update the draft if there is any need for it as well. Thanks.
That's great to hear. So regarding the early allocations, since that's something we can do, are there any objections to doing those early allocations? I guess, Greg, we had gotten a lot of comments from you before. Do we think it's okay to go ahead and ask Ayanna for that now?
Okay. I haven't thought about it as objections. I haven't thought of my comments as objections. So it was comments, and as Rakesh pointed out, so we had a meeting and we realized that there are many ways to, the problem that this draft addresses is real operational problems. So now we started to work on a little bit different approach to addressing the same problem. So yeah, it's perfectly fine to go and help with the implementations and get the early IANA. So to put it on a good footing.
Great, thank you, thank you, Greg. Then,
Thank you, Greg.
We'll continue with that then. Yeah.
Okay, yeah. Okay, thanks.
Awesome.
Al.
Hi, everybody. I apologize for my voice. I've got a vocal cord problem, and I'll go to the video here briefly. To slots for the media are already taken. Blah blah. Okay.
Do you want to share your screen?
No, I just want to. I screwed up. Sorry. Let me cancel that. I just wanted to wave to everybody. Hi.
Hello.
And now I'll stop the video to keep from bombing either my audio or my wife's class. So yeah, hi. We've made some real substantial progress in the last interim period between meetings, and that's thanks to Tommy and Marcus for initiating the sector review, and thanks to Brian Weiss, who has responded to us twice now. And so this first page is mostly about the comments we've already resolved in the 02 of the draft. And then we got some more comments, and we had some open issues. So we're going to go on with that as you know in the remaining slides. But let me say this, that I think a lot of things have come out of the sector review that are really valuable for anybody designing an active measurement or a protocol to deliver that active measurement. And so I want people to think in those terms. You know, how can I apply this to what I'm doing? It's certainly more applicable to anything beyond the capacity protocol. And the truth is, the capacity protocol is more applicable to things beyond just measuring capacity. We've been measuring loss, latency, reordering, duplication. We've been measuring everything since day one. So those are the, you know, it's really lined up very well in UDP-based transport to measure what everybody needs to measure. Excuse me. So there were two categories of changes, the text clarifications alone and the text plus protocol modifications. So the text is clarified in 02. We also clarified that we used a conventional communication setup with a well-known port at the server, and Brian's observation that authentication mode can help us with protections for features like bit error checking. Let's see. So, like I said, all that sort of stuff is in touched on in 02, and we had the original idea of 4 security modes for operation. The unauthenticated and the password auth coded is implemented, but authorizing for all the important messages and encrypt all the things. We were looking for one more recommendation on item D here, and that's been a topic of the other messages we've exchanged recently. So if we go on to slide 3 here, Brian, or not Brian, Tommy, or whoever's doing it. Who is it? Is it Tommy? Okay, thanks, Tommy.
I'm doing the slides.
Yeah, cool. Thank you. So the main things to keep in mind here, this is the previous draft and the current draft described protocol version 9. And that looks like this. We've got a setup exchange, we've got a test activation exchange, and those are both parts of the setup phase. And we look on those differently from the test phase in terms of their demands on the hosts and their requirements on the information they expose and also exchange. So these in red, we were in 01 of the draft, we were adding the server admission control and also the load adjustment algorithm check. So we had the ability to modify the load adjustment algorithm already built into the protocol. We'll get into that a little more than the next slide. So we're actually further down. So slide 4 there, Tommy. Thanks. So now we're looking at the next version of the protocol and the next version of the draft. And we've still got the setup exchange, still got the test activation exchange. And what Brian's basically asking us to do is to add the auth digest and processing on the reply in this test setup. So that would make a complete authenticated exchange for the initial commands for things like the ephemeral port and the bandwidth admission check and so forth. And then what he's also asking us to do is to add the authentication digest on the request and reply for the test activation exchange. So that's an important add. We think we can do this. Obviously, it means a protocol modification and updating the fields and so forth, but that seems doable. So then a little more controversy comes when we get to the load PDUs and the feedback messages. So let me talk about the feedback messages first. We're sending these load PDUs. We're What the heck is this? Lies, more lies, and browser user agent strings from Rich Saltz. I don't know what the hell that means, Rich. Are you in this meeting? I guess not. Okay. So, so when the load PDUs are falling in the test phase, we've got this feedback messages at 50 millisecond default. And that's where we would communicate the loss, the delay, the receive rates, all the other parameters I mentioned, like reordering and delay variation. And if the server is making these measurements, then the server sends the new sending rate down to the client for an upstream test. So that means sending the sending rate structure down. And basically, Brian's question here is, can we add the authentication digest and processing to the feedback messages? And yeah, so this is what we'd like to do is to probably do this. It's probably going to be an additional option beyond authenticating the control phase, the setup phase here, and but it seems worthwhile to try to do that. I'll also note that we've got rates up to 40 gigabits per second now in the sending rate table of the running code and the and allowed for it in the basically in the protocol. So that's cool. But the place where we're having problems is in basically adding the authentication digest and processing on the load PDUs, because obviously to measure capacity, we're sending a lot of them. We're going to encounter hosts either at the client or the server or both that have processing limitations. And so, you're going to see us pushing back on the idea of authenticating every packet in the load PDU stream when we've got so much other stuff to do. All right. So 3 things to keep in mind: test setup, test activation. They're the control exchanges. They're the things that we would probably be easily able to authenticate, also probably encrypt. And if we were to imply encryption, then we'd also need an additional packet to open an ephemeral port on the firewall. Brian really looked at our firewall operations and gave us some really good advice on that. And this is the kind of stuff, firewall at the server end. This is the kind of stuff that would be really useful for anybody planning an active protocol and installing it in the network. So these are all the things to keep in mind, as I go through the details now. Tommy, you can switch to slide 5. We may need to go back to slide 4 here occasionally, but let's try to just go ahead. So the firewall operation at the client basically initiates all the exchanges. So we punch our own pinholes in the client, and we're okay. At the server, though, our current practice is that we open an ephemeral port range. So whatever port range comes back from the client, we basically allow that. And but if we put that dummy packet in, as I just showed, that would open the pinhole on the client for the client firewall for the the two-way exchange and the test activation, and that seems likely to work whether we encrypt or whether we just authenticate. So I think we can probably handle that with at least one more dummy packet. So that's again a protocol modification that we'll be looking at. So then moving on here, we need to look at reorganizing the mode of operations. Same thing, yeah. So basically, based on Brian's input, we're looking at required authentication for the control modes messages. The test setup exchange and the test activation exchange, they would both be authenticated in a required mode of operation. So we could have optional authentication for the data messages and maybe only status, as I mentioned. optional encryption for the setup messages, and maybe the activation messages too. Maybe use DTLS for with those exchanges, and also maybe, and this is a big maybe reuse the keying from the from the DTLS in the authentication aspects. Then we'd also have this optional unauthenticated mode, which obviously we've got working now. So, you know, those are, that's our reading of the current requirements and options for the various modes of operation. I haven't got these lettered yet, but that's what we're working with. Next slide, please, Tommy. So, yeah, so going in deeper here, we'd prefer not to add the auth digest on the load PDU. The only real information there is like the control information is the bits that we flip to stop the test. And if an attacker clears the stop bits, the tests are going to stop anyway after a timeout with the test duration already specified. That comes during test activation. If an attacker adds the stop bits, you know, jumping in on a message, then premature end of test, you'll see that, but it's no threat to the internet, just kind of annoying. And adding the SHA-256 auth digest, that significantly increases the minimum packet sizes. So basically, we're trying to avoid that if we possibly can, and you know, we think we can do that. On the other hand, with the status PDU, there's stuff to protect here, integrity-wise. As I mentioned, the new measurements or the sending rate command, and the sampled RTT measurements. Those are all, you know, sort of important to protect. So it seems viable to protect those with the auth digest. But we need to keep the fact that round trip time measurements are taking place on that 50 millisecond feedback. So you know, it's the old trade-off between accuracy and security protections. Got to keep that in mind. Next slide, please, Tommy. Okay, key management. So this is a brand new thing that Brian has raised. It's good to know about. We're currently using manually configured keys, one per server. He suggested we look into RC 7210, which we'll do. If we add a key identifier, that could help us to do the key management. We don't have that. We don't also have a config file for the key and the ID. So, you know, these are things we could look into adding. Brian suggests, or we could add a section just describing the orderly key rollover. So there's lots of options there. But this is you know, it's an excellent feedback, and really glad to get it. So then the DTLS for confidentiality in the setup phase. It adds retransmission and ordered delivery. Those are good things, but with the cost of you know, like a fairly significant DTLS setup, as I understand it. So you know, I've been looking at the pictures, and I see Tommy nodding there. It's a you know, it's something to keep in mind. If we were to do that on both the test setup and test activation, then we need a dummy packet from the server to open up the firewall at the server side, a dummy packet at the client to open up before the load PDUs, and that's the packet, dummy packet exchange. So we need probably to wait for time for the dummy packets to go back and forth, and then we'd be able to operate fairly safely on the new ephemeral port and the original ephemeral port from the client. But you know, it all seems possible. So you know, we're going to look into doing that. And then again, this, I mentioned the deriving key from the DTLS session. We'd be looking at that on the feedback messages, and if we're wondering if we've got the support necessary for that in the open SSL from the DTLS session. It's a question, so that's an open issue. Next slide there, please, Tommy. All right, so we've got the topic of silent rejection during the setup phase. In authenticated mode, we'd likely use silent rejection now because we don't really know where the requests come from. There's no authentication. But if we've got a successful validation of authentication, then we could return the full rejection message with the area code. We've sorted this out in follow-up and discussions with Brian. And if we have authenticated mode with failed authentication, we could have the silent rejection again. On the other hand, compile time to help troubleshooting, we could turn on turn on non-silent for troubleshooting. That would be probably a good thing. So, these are things we can look at doing. Also, the client does not currently validate the server setup response. I think I mentioned that in the picture. And so we need to be sure that the auth digest checking lists and expanding that would fix it to check on the in the setup response. All sort of doable in my mind. The auth Unix time is not a complete protection of against replay attacks. Brian pointed that out. It's a we could add in a record of previously received messages within that window, and we could add an ID which can't be replayed with the same HMAC. But the the idea is this is an infrequent diagnostic message. We can't measure capacity all the time, and also we're not NORAD here, so maybe we could not worry about this quite so much, but the ID might help. So those are things we're thinking about, ways to solve them. And again, thanks for the comments. So next slide there, Brian, or Tommy. So the kind of the summary that came up in Brian's mode D encrypt all the things. This is the safe advice. The strong authentication for all methods is a good choice. We've got that for all of them that we think we can do. Make it optional for a site to deploy. That sounds good. Require it on the authentication of the setup messages. So we're going to have a mode for that. Make authentication optional on the data plane. That seems defensible to Brian, and because he understands the effect on the test accuracy. The next sector their reviewer or the ADs, they might not understand that. So we got to make that clear. And since orderly key rollover is a good thing to have, so we'll look into adding the features to support that, and also DTLS and reusing the keys possibly. So that's a good summary, I think, of all the kinds of things we're looking into. But notice that Brian asked the question, look, he said, I haven't seen anywhere that full encryption is a requirement. And I took it from the wording of privacy is the default, in the pervasive monitoring is an attack, RFC, and also from Ted Hardy saying that encryption has to be on by default in IETF protocols, but that's not written down anywhere. So look, if the authentication and the encrypted setup is enough, then I'd really like to hear that from the ADs that are ultimately going to have to review this thing, because we could do that very easily. But putting this all in a tunnel, it's going to make it's going to have an impact on the measurements. It's going to have an impact on the host that can perform it. And note that it's basically not in this list. So this is Brian's advice. He's not speaking for the sector. He's not speaking for the ADs, but this is all very reasonable to us. So, we can do this, I think. And that's where we're going to go for now. be great if we could hear. We want you to do 2 more things too. So anyway, let's keep bugging people about that. Next slide, please, Tony. So we finally get to something fun to look at. I mentioned that we can have new types of algorithms supported by the protocol. So here I've got a plot where we've got megabits per second on a DOCSIS downlink up to 1,000 megabits or 1 gigabit. And I'm comparing on the left the type B algorithm, which is the current default, to a new algorithm, which we're calling type C, and which is implemented in the new running code. So let's look at these measurements. Basically, it's 2 10-second tests in series on the 1 gigabit downlink measurement. It's the UDP 7.5.0 in debug mode, and we've got the 50 millisecond feedback measurement. You can get that from the debug, and packet loss measurements are in blue, so you see those counts. And type B is fairly nice to the network. We get some bursts of loss here, but not much when we're testing kind of in the steady state at the maximum. Now, the big difference between type B and type C is that we're going to continue to retry a fast ramp-up mode. And the fast ramp-up mode is very different. Instead of being linear at a factor of 10, it's now multiplicative at a factor of 1.5, the current sending rate. By the way, that's a good thing. And what we see here is the IP layer bit rate in the 50 millisecond and also the 1 second subinterval measurements. You may recall that we take an average of the 50 millisecond measurements every second. And this one second rise to the gigabit range is very valuable in the mobile testing. And if you want to have short intervals of testing like 5 seconds or things like that, or if you're in mobile and you expect lots of variation in your maximum data rate because you're switching back and forth between 5G and the other, then type C algorithm is for you. I note that the RTT variation is kind of an underestimate. The servers and everything else here are kind of limited to 1 gigabit. So you would expect if we had greater bandwidths than the bottleneck on the DOCSIS downlink, we'd probably see the delay climbing up here. And then we have a real higher delay measurement of responsiveness here. But the key thing is that we can basically measure responsiveness when it matters. And we do that in the same context as Ookla speed test. We do it in the same context as the capacity tests and in the responsiveness metric as I'm reading it. The big difference is that we're making the measurements at UDP and not at TCP or HTTP. So it's kind of a complementary thing to the other measurements that have been proposed. So
we have Martin in the queue. Would you like to take his comment now, or would you like to take it later?
yeah, sure. Go ahead, Martin.
Yeah, let's give your poor vocal cords a chance to relax. Do you anticipate delivering this document to me in the next 6 months or so?
Yeah, I hope so. I hope we can.
So, like, I mean, you asked me to refer to the previous conversation about like what we'll get through the ISG. I don't want to presume to speak for Roman or Paul. And I personally, don't have a strong position on it. Maybe it would be good to just start, like, rather than sort of guess, maybe we should just like start a dialogue with them. And, I'm happy to be included. We can just start discussing like, how much of a deal breaker is this for them? What are the costs to this system if we do have to encrypt everything? And you mentioned them in your talk, but just like kind of capture those trade-offs and kind of see what they say rather than guess wrong.
Yeah, thank you. Especially since we've got running code that we're trying to keep up to date here. And that's Yeah, I don't want to throw away any code.
Yeah, yeah, it's not, and like I said, the reason I asked about the 6 months is because, of course, there'll be different ADs next.
Yeah, yeah, that's a good point. So at least we'll keep one of them though, right? Okay, good. Thanks, Martin. I'll do that, and we can refer to the sector reviews as well. Thank you. Next steps: reviews, test experiences, comments are welcome. The implementations are happening. You can see this diagram here where it basically says, look, there's pins popping up. Looks like a roadmap to me. That's because we've talked to lots of people who are doing this. And we're really looking forward to everybody's input and ideas on how to do this. And additionally, what we can do with it. And in the backup slides, you'll see that we can implement alternative rates of rate programming to emulate applications. So that's a really valuable feature of this protocol. And this, it's not just capacity, it's almost anything you can imagine that you can write the load adjustment system for. It can be static and it can be dynamic based on the measurement feedback. So think about this. I'm almost sorry I called it a capacity measurement protocol because we can do so much more than that. So thanks everybody for your attention. And we can, I guess we can just run on here now. There is a comment there from Will Hawkins. Also have the same feedback and problem in responsiveness. The presence of encryption in the protocol means that it's more difficult to measure low power limit devices. We think this problem is significant. So Will's basically agreeing with me. We gotta let the measurement side of this go loose on encryption to get effectively the right answers. Thank you, Will. And Edward says it looks like we lost the room.
I don't know if you can hear us from the room, Al and everyone. We have some network issues here, so kind of MeetEcho is offline in this room. So we'll try to get back to you as soon as we can, as we have this fixed.
Okay, thanks. I think I'm pretty much done though.
Yeah,
So we can,
I think you hear us because I enabled my local microphone here, but we'll hopefully get this fixed as soon as possible.
do you want me to share some slides or something like that to keep going?
Did it sound like it was just our room? Or, I didn't ask any call. They seem busy, but yeah.
Yep. All right, it looks like we are coming back online over here. Al, do you want to try talking and seeing if the room can hear you? Assuming you can
Yes.
hear me. Okay,
Yeah, I
great.
can hear
We're
you
back.
talking. Yeah.
All right.
Yeah, I don't want to take up any more time. Thanks everybody for your attention and feedback.
Yeah, actually, Al, I did have a couple comments myself.
Cool, go.
If that's fine. So, I mean, in general, I think the approach and sentiments you're expressing, I agree with a lot. Actually, could we jump back to like slide? Is it 5? or one more, 6. Oh, yeah, yeah. So when we're talking about the authentication of the data, the actual load packets, which I would certainly agree that that doesn't seem like a great idea to try to add more authentication to those, since it's a pretty minimal attack. I have a couple of questions. So you mentioned the 3-second timeout here. Is that a negotiated timeout in the kind of initial test setup, such that that is just an example time, or is that a fixed time in the document?
It's a fixed time in the protocol. It's basically a pound to fine. And
Got it.
okay.
And then I was also wondering, like if for some reason we get pushback on not having these authenticated, kind of going into, what do we actually think an attacker could do with this would be good. I mean, you mentioned they could, stop the test prematurely. Would there be something we could potentially do at the end, either in a status feedback or it seems like the final message, which would be authenticated, to indicate if one side thought it sent a stop, or just essentially detect after the fact that something like a stop bit was set by an attacker, so you could just confirm that yes, we ran this test and there were the number of stops that we expected to see, or there was a mismatch, and so we should throw this result out.
Yeah, I think the client can send its own stop bit, and that that would either be it would either be in the load if it's an upstream test, or in the feedback if it's a downstream test, and both the client and the server have the timeouts for ending the test.
Okay. Thanks for clarifying. All right. Yeah, I can share. Do you want to? I think you have to stop sharing. Okay. What measurements?
Igor.
Hello? Oh, working, great. So I'm Igor Lubashev. I'm going to talk here about the explicit flow measurement. That's a draft that's in the working group last call. If you recall, if you've been following it, it's been basically merged together from 2 different drafts that explore slightly different techniques to solve a very similar problem. That's why we have quite a list of authors here. Nothing has much changed since the last call, so we have the same version of the draft. We haven't received a whole ton of feedback on last call, maybe because it's perfect, but so I'll take this opportunity to kind of reintroduce the problem and show you what we've come up with, and then ask for, hey, if you do have some comments for during the last call, I mean, it's awesome time to give them and to improve things. So the problem is, well, network operators need to be able to troubleshoot problems such as loss and latency issues, and I mean, detect them first. And to do that, it's really best to actually be able to observe the problem, because otherwise a response to a trouble call is, we looked at a few statistics here and there, we saw nothing. Sorry. That might be just well, maybe you haven't looked enough, maybe you should look at a few more. So with protocols like TCP, as the last resort, you could pull out a Wireshark and try to observe the problem as it's happening. If somebody is saying that you have loss in your network and you can't find it, so observe it. With encrypted protocols, that's not going to work well, because the transports are encrypting all the headers, everything that would be useful for this purpose. And they're doing it for a good reason. I mean, at least good enough reason. Number one concern is all that clear text stuff could leak some information that could be considered to disclose more stuff than endpoints wish to disclose, so privacy risk. And the second concern is that on-path devices trying to be super helpful, to be able to be very helpful, need to understand what they're seeing, and when they understand what they're seeing, they don't understand anything different, and may cause problems. And as an effect, you have protocol ossification that basically you just can't do any innovations, do any changes. We're all familiar with that. So that's like another reason why some of them, looking at Quick, of course, encrypted transports chose to encrypt as much information as possible. There are other uses for these techniques that are unrelated to encrypted transports. So we're trying to find, develop techniques that can be used with just a few bits, like really, really a few, like 1 or 2, 3, that would be enough to figure out quite a bit of information about any problem that's happening. The advantage of having just a few bits is that, first of all, fewer bits means it's easier to do any sort of privacy security analysis. You're much less likely to leak stuff inadvertently, especially if your bits are purpose-built and not built for some other purpose. And second is that an explicit signal, as opposed to implied signal from transport headers, means that it's not integral to the operation of the transport, which means you can just turn it off, or you can only enable it selectively when you need it. You can grease them, and that will help against protocol ossification. Next, please. Some of the prior art, latency spin bit, after quite a bit of debate in Quick working group, it's been added to Quick version 1, and its purpose is to be able to measure round-trip latency. Now, in this draft, we add a whole ton of additional bits that are designed to do particular measurements, latency measurements, and different kinds of loss measurements. They can be used together in combinations. Next. Some of them, again, the goal is not to read the eye chart and like everything's, this table is in the draft. But the idea is that we're discussing what different bits do. We compare their performance in terms of fidelity versus latency of the measurement versus how many measurements you can do on a particular flow. So that's about latency. Next. And similar for loss, we have many different loss metrics you can derive from using different bits or their combinations. Again, we have a bunch of analysis for comparing different alternatives, what you can do with just 2 bits, 1 bit, trade-off between, again, fidelity and how quickly you can see loss after it's happened. Do you see loss shape, or do you see just approximate average loss per connection, round trip? Anyway, so a lot of different analysis here. Next.
Sorry, Igor, do you want to take a comment now from Martin? Or
yeah, I'll take a comment.
Hey, Igor, Martin Duke, Google. The square bit in particular seems to have a lot of overlap with 8321. Which is this
Sure.
is this a standard, proposed standard?
Informational.
Okay, so like one, like I think we should probably figure out where we're gonna like discuss and specify this square bit thing, unless it's just referring to that draft.
So it is referring to, I mean, it's square bit was not invented here.
Yeah, okay.
It is just one of the signals.
Right.
So the purpose of the draft is not to specify bits on the wire.
Uh-huh.
That will be up to the protocols, how they choose to implement it.
Sure.
The purpose is to give you techniques, to analyze techniques, and basically to say that's what
Yeah.
you can do with as many bits as you want to spare.
Yeah. Well, I mean, 8321, even though it's currently experimental and headed for standards, I guess, it's the same thing. It is not attached to a protocol, and I guess there are other drafts that are instantiating that. But also interestingly, I think they've gone away from the end packets to having like a time interval. So I don't know. I think we should get our story straight on that. But
yeah, I think that's exactly the kind of feedback that's totally awesome, and
Okay.
we can discuss. Looks like Giuseppe, he's a co-author here. Maybe he wants to also
Wonderful.
add
Thanks.
something.
Giuseppe?
Hello, can you hear me?
Yep.
Yeah, just to answer to Martin's point. Yeah, the square bit is introduced also in the 8321. But yeah, the difference, as you know, that in the 8321, in particular in the proposed standard document, we focus only on fixed timer blocks, while the square bit is based on fixed number. So in case, of course, this will be standard track, I mean, the explicit flow measurement, this will need an accurate detailed as we do in the 8321.
yeah, and I just want to clarify that I technically have no dog in this fight, but like I think the community should decide the best way to do this, because 8321 had both, and 8321 this is down selecting to time. So like I said,
And that's fine.
Yeah.
I mean, whatever works best for the purpose, right? I mean, if we decide time works fine, fine. But if we decide that we look at time and say, it has problems for the purpose,
Mhm.
I mean, what's important is that it's fit for the purpose.
yeah, absolutely.
Yeah.
And
I mean, if the name clash is a problem, we can obviously rename it.
well, I mean, I don't think it's a question of name clashing. I think name clashing. I think if you're going to use that, if you're going to use a bit for loss detection, I think communities to decide how that works, and whether it's this or whether it's packets or time, either one, but we should decide. Thanks.
Okay, thank you. All right, next slide. Tommy. Yeah.
Just a comment on that. So does the current document where it defines the square bit talk about the time option, or does it only describe the?
No, it talks about packets.
Yes. I mean, what I would suggest, given that this is informational and it's kind of laying out, here's the zoo of all of the different bits. This should just describe both. Say, hey, you can do it based on time. You can do it based on number of packets. This other document over here chose to do it based on time. Here's why you would want to do that. But if in the future someone has a really good reason why they want to do it based on packets, that also exists.
Okay, thank you.
Sorry, I just I think that's reasonable. With the caveat that like if 8321 bits is the pro standard, we really have community consensus that is the best way to go forward. Then we should probably make sure that's clear in any informational document.
And yeah, totally, we should discuss it. Yeah, thank you. All right, so this slide is basically talking about this being actually in use. There is a number of industry implementations. So for example, Akamai Orange implemented it and ran this for about a year in production. We've made, actually no, can we go back?
We're a little bit short on time.
Out of time. Okay, very good. So I'll just summarize a number of implementations from different operators, a number of implementations from researchers. So that's been done. And just it's the last slide. The quick history of it is that we've been running last call since July 6th. We just received on the list substantive good feedback from Marcus about some hidden parts of the delay bits. Just now feedback from Martin. So let's, looks like we need another revision of it. Let's discuss on the list. Probably we want to extend the last call and get another revision in.
Yeah, probably maybe get another revision in and make a new last call at a later point. Yeah.
Okay.
Yeah.
Thank you.
All right, so next I think we have responsiveness, and Christoph, I think Billy wanted to share his own slides. So I'll let him go
Hello,
do that.
yes, I would like to share my screen. That way you can see animations, which will make it easier to visualize the changes. Let's share the screen, yes. Let me know if it does not work.
We see it.
So now you should see it in the presentation mode.
Yes.
Great. So, hello, yes, this is responsiveness under working conditions. We submitted a 0.1 version shortly before this meeting here. The update from 0.01 to 0.1 is the mill is listed here. We closed a set of GitHub issues. We merged a few PRs, got a few contributions. And in terms of the significant changes, there's first, Stuart Cheshire added DNS-based service discovery for the network quality measurement or the responsiveness measurement. That way, it means that if I am on my network, I can basically browse these DNS-based services that are being the services that are being announced through DNS. I can discover them on my local network and thus discover endpoints on my network that allow me to test the responsiveness in my local network. So we hope that this is going to be a very useful addition. We added server-side example configurations in the appendix so that if people want to deploy a responsiveness measurement endpoint, they can simply take a look at those example configurations. And we did a significant rework of the measurement algorithm, and of course some wording changes, minor fixes, and so on. So I want to double click on the significant rework of the measurement algorithm. So how was the previous algorithm? And so the previous algorithm, its goal was to find the point of good put saturation. And the way it worked was the following. We started with a set of connections, by default 4 connections. And at one point we reach the maximum good put with those 4 connections. And it starts leveling off. At this point, the question is whether we would be able to achieve higher good put by adding more connections, because the BDP of the path is very large, right? And so the only point to do this is we were adding more connections, right? Until we reach the maximum good put, at which point it levels off again. And so now the question becomes, well, did we actually reach the link capacity? Yes or no? Or do we still need to add more connections? To learn this, we add yet more connections into the pool until we realize, well, okay, the good put didn't change, so there's no change in good put, and so we declare saturation. At which point we started the latency probes, right? We sent a set of probes on the load generating connections and a set of probes on the separate connections. So what are the problems with this approach? So the first problem is that we only have a very small sample size, right? Because at the point when we reach a good put saturation, there might already be very high buffer load, and so sending those probes might take quite a long time. And so we can only send a very limited number of those probes. So the sample size is pretty small. On extremely buffer bloated links that have several seconds of buffer load, these latency probes have a tendency to time out. So we may sometimes not even be able to get a measurement. And finally, these kind of one-shot measurement that are happening only at one point in time have the tendency to be impacted by short-term buffer occupancy variations, right? We have seen cases where there is, on these load-generating connections, there's an effect of what we call a synchronized packet loss, where all of these connections get a packet loss at the same time. So all of these are at the same time reducing their congestion window. And so they are all of these at the same time reducing the buffer occupancy. And so sending these one-shot measurement probes has the impact of being, has the result of being impacted by these short-term buffer occupancy fluctuations. So these here are the drawbacks of this algorithm. So what we realize is the way we can actually solve most of these problems is by basically, well, we keep on trying to reach capacity, right? But instead of waiting until saturation to start the probing, we start probing right away. And we probe every 100 milliseconds. We probe on separate connections, and we probe on the load generating connections. And we just keep on going through the algorithm, and we continuously probe every 100 milliseconds. We send one probe on the first load generating connection and one probe on the separate connection. So what does this mean? As you can already see graphically, right, we have a lot of probes now, right? And so we get 4 data sets with this approach. We get latency on the separate connections, we get TCP handshake latency, we get TLS handshake latency, and we get HTTP request response latency on the separate connections. On the load generating connection, what we call self, we get also a HTTP request response latency. And so those are now very large data sets, right? Because we have sent lots of probes. So how do we aggregate all of these 4 data sets into a single number? First of all, we take the 90th percentile, right? So that way we filter out those probes that were happening at the beginning of the test when the link was not yet buffer uploaded. Then we need to weigh those 4 different numbers, right? And so our goal is to put equal weight on the load generating and on the separate connections. Now for the separate connections, we get 3 data points, right? The TCP handshake latency, the TLS handshake latency, and the HTTP latency. And so we weigh these in the way we show it here in the slides. We give 1/6 for each of the separate data points and half for on the load generating data points. That way, both are weighted equally. Now this is going to give us a number in terms of seconds. And so as we want to express responsiveness in terms of round trips per minute, we basically normalize it to RPM. For those interested, this is the final formula, 60,000 divided by the P90 of the different values, appropriately weighted the way we have described it. So the advantages of this approach is, first, we have a very large sample size, about 150 data points for 15-second test, which is great, which removes a lot of variance, which avoids all of the issues that we described earlier. We have much less timeout issues because the probing happens right from the start. So even if you have a link that has huge buffer upload, we usually end up to get quite a few samples of this very huge buffer upload scenario. And there are no more short-term fluctuations because of the huge data size and the huge sample size we have. This has been implemented in macOS Ventura, the upcoming macOS release, and the network quality tool, and the open source Go responsiveness tool has it implemented as well. Now, in terms of the remaining issues, there are a few more remaining issues that we would like to address. Issue number 17 on the GitHub is we would like to use a well-known URI for the JSON config. That way, any web service could basically expose this responsiveness measurement as a service, and we could simply discover it by hitting the well-known URI to see if there's a JSON config available. Issue number 63, we need to explain the impact of congestion control. It came up in the past, but we haven't yet had the time to address this question, and we want to write a section on how the different congestion control algorithms like cubic, BBR, and so on can affect the responsiveness. Issue number 55, we want to provide guidance on how we can provide an estimate of how confident we are in the values of the results. Because there are different ways of how the algorithm can evolve, and because we may hit timing issues, sometimes the numbers may be more or less accurate, because the goal is to provide a measurement of responsiveness within a reasonable time frame. Sometimes, in order to provide a result within less than 30 seconds, we have to give a lower confidence in the result. Issue number 66, what Al also brought up, is we need to allow non-TLS measurements, because on some low-end devices, if we want to allow, for example, that your router exposes the DNS servers, the servers through DNS-based discovery, right? Lower-end gateways usually don't have the performance to actually fill the link with TLS traffic and self-generated TLS traffic, and so we want to allow for non-TLS measurements. And finally, the most important one, Stuart Cheshire filed an issue, number 62, called the flaw in the working conditions algorithm. And I want to double click on this one, because to explain what is the problem and how we can solve it. So if we look at what I explained earlier in terms of our algorithm, right, we are trying to reach the maximum good put. Now, good put is actually not what we are measuring. We are trying to measure responsiveness, which is the buffer bloat. And so it means we are trying to measure the buffer occupancy. So the bottleneck link that is driving the maximum good put has a certain size. It has a maximum buffer occupancy. And for sake of examples here, we say, let's say this size is 64 megabytes. It's a very buffer bloated link, right? So as we go through the algorithm, and as we start with 4 connections, right? And often one TCP connection has frequently a limit in terms of how much data it can put in flight. And for someone, typically this can be around 4 megabytes, 8 megabytes, 6 megabytes. For this example, let's pick 4 megabytes, right? So we have 4 connections with a maximum of in-flight data of being 4 megabytes. That would give us a maximum of in-flight data of 16 megabytes, which means, as we are on the top graph, right, we have created those 4 connections and we are leveling out in terms of good put. We haven't, however, yet achieved the maximum good put, which means the buffer occupancy will be 0, right? There's no buffer bloat yet happening. Now, our algorithm decides to add more connections. Let's say we are at 8 connections now, okay? So 8 connections times 4 megabyte means 16 megabytes. So however, we are still reaching to the good puts. We haven't yet reached this point of inclination where we are actually creating buffer bloat. Now, as we reach the maximum good put, we actually start building a queue now. And so now the queue starts filling up. But as it's only 8 connections, which means 16 megabytes worth of buffer occupancy, we haven't yet completely filled the link. We are only at 64 megabytes. We are only at 16 megabytes on a 64 megabyte buffer, right? Now our algorithm keeps on adding more connections, right? So now we are at 12 connections and the buffer occupancy keeps on increasing. Now at this point in time, we realize, okay, we reached capacity for the good put, and so we declare saturation and we terminate the test. What does this mean? Well, this means that this is the responsiveness that we measured, but in reality, the responsiveness is much, much worse, right? We haven't even yet filled the buffer completely. So what is the solution to this problem, right? Well, the solution is we go through this algorithm, but then we see that, well, actually the responsiveness is still evolving, right? We haven't leveled out the responsiveness yet. And as we realize that, okay, with 12 connections, we reach 48 megabytes of buffer occupancy. And so we can say, okay, we leveled out at 12 connections. Let's add more connections to see if we can push it even higher. So we add more connections and we realize that the buffer occupancy is increasing. Now with 16 connections, we had 64 megabytes worth of buffering, and so we actually achieved the full buffer occupancy. The only way for us to find out whether really we achieved the full buffer occupancy is by have one more iteration of adding more connections, and we realize by adding more connections, the good put is not changing, nor is the buffer occupancy changing. And so it means we can declare saturation and we can declare the final responsiveness result. So this is the new algorithm. So it means that we not only need to saturate good put, but we also need to saturate responsiveness. And once good put and responsiveness stop changing, we declare saturation. And so in the draft for the upcoming version, what we need to change is, in terms of the algorithm, is that we are adding connections as long as either good put increases or the responsiveness is decreasing. So this is going to be the new algorithm for the next for the upcoming version. In terms of other news, the open source Go responsiveness implementation is evolving rapidly, and of course we would like people to try it out. We invite everyone to test it. Will here is on this call, and would be very happy to get pull requests and GitHub issues as well. In terms of the other implementations, Ookla speed test now started measuring load and latency as well. We don't know details about how they do this, but it's probably a very similar measurement methodology. So the load and latency in Ookla is going to increase also the awareness on the issue of buffer bloat and responsiveness under working conditions. So with that, I'm at the end of the presentation, and if there are any questions, I would be very happy to take them.
Thank you very much, Christoph. Al.
Christoph and Will, for your work on this. I think that the one thing you're going to want to fix in the draft is the equation for responsiveness. I was about to do something with it, and I noticed that instead of 1/6, you've got 1/3 in all the denominators there, excepting the last one. So I was confused by that, but I see now that you mean 1/6, and it sort of adds up to 1 with the half-weighted aspect. I think that when you're reporting capacity, it's based on a lot of connections, and that's the then I tried it out. On a couple of cases, I saw 20 connections, and so forth. And those are, you're going to get. If Matt Mathis was probably here too, he would say the same thing. You're going to get opportunities for synchronization and the interaction between the different TCP algorithms and so forth. Thanks for turning on your video so I can get some feedback. I see you smiling.
Yeah.
I really learned a lot of this from Matt, so I'm just proxying Matt here when I tell you my story. But I think you're on the right track in monitoring the delay as well as the good put. But there's other factors here too that matter, and we've actually been looking at in our capacity measurement, we've been looking at the possibility to reduce some of the factors. We found that reordering and duplication, they happen on 5G networks more prevalently than anyplace else. And the truth is, those are measurements that or packets that are delivered that contribute to capacity. So TCP isn't going to tell you about those. It's going to discard those as it forwards information up the stack. But we can grab those in the UDP measurements, and we end up including the reordered and duplicate packets now. We're thinking about making that the default, especially for mobile testing. So there's lots of room for improvement in our algorithms here. And I'm glad to keep exchanging ideas with you. Thanks.
Sure. Yeah. Thanks for the feedback.
All right. I jumped in queue, not chair hat on, just to comment. Earlier you mentioned the issue about using a well-known. Looking at that, I think there's some debate about, what's in that. Is that just the config? Is that the actual test? Overall, within kind of HTTP, I mean, there's certainly a sentiment that well-known can be overused. I think this is a decent use of it, but I think it'd be worth, if you want to drop a line to Mark Nottingham, who has to review all of those anyway, to see, is this going to be something that would get through the expert review for adding well-known, and any advice there. That'd be good to get. Regarding the new algorithm, I think everything's good. One of the things that came up in the chat, I think there's questions about, like, why would you, for example, not just measure when the responsiveness starts decreasing? And I think the answer to that is, the responsiveness won't actually decrease until there's enough load.
Yeah.
I think then just one edge case came up to me. It's like, are there any scenarios in which the responsiveness only starts decreasing further to the right, such that, like, we could get to 16, and our good put has flattened out, but the responsiveness will only start going up starting at 20 or 24, and so we could actually stop the test too soon. Is that something we should be concerned about?
So on your first comment, yes, absolutely, you're absolutely right. Unless we hit capacity, the responsiveness won't change at all, right? That's the part here on the left. I don't think there's a case where we could hit capacity and only 20 flows farther down the road, responsiveness would start changing. I don't think that's possible. I think the moment we hit capacity, responsiveness will start changing. That's just the way it is. If that would not be the case, I would love to see that.
Just wanted to check.
Yeah, no, absolutely. It's a good point. Absolutely. I just cannot imagine how it could happen.
This is Stuart Cheshire. I'll say a few more words on that. And actually, in the last couple of weeks since the draft deadline, Christoph and I and Randall have been discussing this internally, but it was after the submission deadline. One of the things that I'm starting to think is we might be able to simplify this algorithm. Instead of this current sort of staircase function where we add 4 connections and then wait a bit and then add 4 more, it might have a more elegant simplicity about it if we just add new connections at a 1-second cadence while measuring application error round trip time on those connections. So we're gathering data. And the initial idea in my head to propose a termination condition for this is we add connections once a second and we cease the test when 4 seconds have gone by without either an increase in throughput or an increase in latency. So we kind of keep a high score of the highest throughput we've seen and the highest latency we've seen, and every time we break that record, we record the new record. After we've gone for 4 seconds without setting a new record for either of those things, that means we've added 4 more connections, we've put more data into the pipe, and neither has changed. And just to back up a little bit to second what Christoph was saying, as we have more data in flight, initially we fill up the BDP of the pipe, which is good because we're getting throughput. And when we hit that limit, additional data is now sitting in buffer somewhere. We may not detect that instantaneously, but I think over a 4-second window, if we're continuing to add more data in flight, then within 4 seconds, we will have seen the delay go up, and that will cause us to keep testing until delay stops going up. So that's your answer, Tommy. I think if we didn't have that 4-second window, there would be a risk of a premature exit. But that 4 seconds, I think, is what makes it work.
Thank you.
Yes.
I think we need to move on a bit quicker, a bit over time.
Okay.
For this.
So I'll just say the thing I came up to the microphone to say originally to explain a bit more about. Christoph mentioned the DNS service discovery service type. The motivation for that is I may run the network quality test and get a lousy score, but as an engineer, I want to know why. So we've been talking to home gateway vendors and Wi-Fi access point vendors who actually want to host a test endpoint on their Wi-Fi access point or on their home gateway, so you can eliminate the cable modem or the DSL from the equation and do a local test and see, is it my Wi-Fi or is it my cable modem that's causing the problem? So that's the reason we want that auto discovery. And if there are any other home gateway vendors interested, then talk to us about how to host one of those test endpoints locally.
Ignacio?
Hi, could you hear me?
Yep.
Okay. Well, just small comment about this technique to measure bandwidth. I'm not sure how noisy it is because you know, inside the network you got some other traffics, and perhaps I'm not sure if you are just measuring just I don't know, the last mile or something like that, or you are measuring something more bigger than that. But I imagine that there is some traffic, more traffic, and could be a little noisy. I mean, the responsiveness is not like a straight line, like you draw line there. Therefore, how you deal with this variation, because could be really very important when you go through several links. Thank you.
Yeah, thanks for your comment. So maybe I didn't introduce that properly at the beginning. What we are measuring here is end-to-end capacity and end-to-end responsiveness. So from the client to the server, right? So it's not necessarily last mile. It is wherever the bottleneck is for this kind of communication, right? So
okay,
yes,
great.
there may be other traffic, and so we are measuring what at this point in time, what is the user's capacity, that the fair share of its link usage that he can get or she can get.
Okay. Then you got really a lot of noise. Sure. I mean,
Yes.
the signal are very high. Okay, great. I will contact you later. Thank you.
Sounds good. Thanks.
All right. Let's move on. Nalini, do you want to present?
So this is our PDM destination option. It's an IPv6 destination header, and basically what we do, this is an end-to-end measurement. It's put on at the source, at the end client, and we put in a sequence number and timing. The idea is to be able to very quickly separate server time from network time, and the potential users are large enterprises. Okay. And so what have we done? We had an early sector review, and I'll go through that, and we're working on implementation of this. And we're also testing extension headers across the internet, and I'll talk about that. Okay. So this is the sector review, and basically they said it wasn't ready because it's still very early, and there's a few things left to do, basically on authentication, authorization, and so on. And otherwise, they think it's pretty good. And so we will continue to work with them. We feel pretty good because it doesn't look like there's huge amounts to change, and we'll address whatever there is. So that feels good. Okay, next. So the big thing that we did this last time, other than implementation, is look and see, can IPv6 extension headers can actually be used? Because if they can't, we're wasting our time in defining this thing. It doesn't matter, encrypted or not, it won't work. So that's what we did. And so we tested stuff. So next. And so what we did, and so what we did, and this is the start of the testing. And yes, we know we need to do a lot more, and we're working on doing a lot more. But basically, what I think we showed is that we did a patch to the FreeBSD kernel so that it sends out extension headers with every packet, and we sent real FTPs. So I'll show you that. And the other thing we did is we did it across on a couple of different continents, maybe, 3 different continents, 4 different, and a bunch of different cities. The idea is to see if it's going through the core of the internet. Because if it's, because we want to find out, is it being stopped at the source? Is it being stopped at some transit network? Is it stopped at the destination? If extension headers are not getting through, then where are they? And ideally, why are they? So next. And so it was real easy because PDM, our mod to the kernel sends PDM with every packet. We can just do a very large FTP, and that's what we did. And this one happens to be Toronto to Mumbai. And you can see it was a big old FTP and successfully transferred. Next, please. And you can see our wonderful little PDM extension header right there in the packet trace. Next, please. And in fact, it turned out a lot of these things were fragmented. And so we didn't even mean to test fragmentation header, but it was fragmented. And all those got through just fine as well. Next. So you can see it appeared to go all the way through for a bunch of different sites. Big old FTP going across. Okay, next, please. And so we also started doing curls. And this one was actually at the hackathon. We started doing it to, I think we set up an Apache server in Warsaw with a bunch of junk data in it. So it would create a bunch of fragment headers, and we tested from the hackathon. And here it is. We're doing a curl from the IETF network successfully. Next. Next, yeah. So we're going to do a lot more testing and to see kind of where things start. And there's already a number of people who want to work with us. We will continue on implementation of our encryption, because ideally PDM will work to give us our wonderful data that we need. And then if it actually works, then we actually do need to encrypt it, because the data is actually too good. It can be the source of an attack. So one does wish to encrypt it. So yeah, there we are.
Martin.
I'm sorry. So maybe I got confused by different. So you're finding the EH is making it through just fine, at least in the limited measurement point you have?
Correct.
Oh, good. Great. Thanks.
Correct. That is indeed what we have found. I'm saying these are the points we tested. These are the tests we did. I'm not saying anything more than that.
Hi, Bob Priska. just say what I said to you when we were chatting in the hackathon.
Yep.
That all the advantage points are data centers. Essentially, they're the hosting services data centers, and so nothing's going over a sort of consumer access network.
No,
So,
no, no, no,
yeah.
no, 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 no. They're just going over the public internet. It is going over the public internet.
Yeah, yeah,
Yep.
but
Uh-huh.
not a consumer access network like a mobile network or a
Oh, yeah,
or
yeah,
a
yeah, yeah,
DSL
yeah.
network or
Yep, yep, yep. We will do mobile testing. We'll do testing.
Yeah.
Yes, yes, yes. No, you're
Yeah.
very right. There's lots of, yeah, yeah. There's lots more testing. Lots of people.
Yeah.
You know, anybody that wishes to help test, knock yourself out. We're setting up an email list. It's, you know, I mean, yeah, yeah. There's a lot more testing that needs to be done. You could not be more correct.
yeah, because I think that's where you're more likely to find problems. But yeah.
Hey, let's just see one step at a time. Let's see where we got
Well,
problems. Because, you know, the other thing too, let's find out what's the situation. Where is it being dropped? Why is it? Because I tell you, just right in our testing at the hackathon, we found one bug in a particular router implementation where the hop by hop header just right there wasn't going out at the source. And so of course the question is, what happened if they fix their bug, right? And like lo and behold, you know, and no, it's super interesting. We're also talking to the free router people. I just had the little young man write me back. We'll modify free router to send HBH, because what I think is if we can bypass, if we can control all the equipment, if we can control the equipment, control the endpoints, and know exactly what it is we're testing, I think we have some shot at figuring out what is the actual situation. Yeah, any feedback or comments or anything that anyone has on, you know, what we're forgetting, you should remember to test this. You know, please let us know. We're happy to test. Yep. More results next time.
Thank you very much.
Thank you.
Greg?
Okay, next slide, please. Okay, so this is updated just to remind you what we're trying to do is there are services that are governed by multiple SLOs that are composing their service level agreement, and they are expressing requirements and expectation of the service for the particular metrics. And in this work, we're trying not to look at how each particular SLO is complied with, but in overall, the combination of multiple SLO, how it reflects their service in as a whole, and we express that as precision availability of the service that is characterized and constrained by multiple SLOs. So if you look at this figure, so you see that their period where their particular SLO, a particular metric is within acceptable range, but then there are periods when it exceeds the critical threshold, and these periods can be considered as service unavailability, whereas when it's acceptable, that's acceptable, and thus it's a service availability period. Next slide, please. So this is update. We already presented it at a virtual meeting in Vienna remotely. We received very detailed and helpful comments from Matt, worked together, and Matt agreed to join us and continue working on this document. So let's look what updates we have now for this meeting to share with you. Next slide, please. So we clarify the problem statement. And so basically what we are trying to solve, what we're addressing, and it's not only on particular values that the service experiences at the given time, at a given point in time, but how it relative to the thresholds, their SLO that is set for their particular metric. Next slide. So then we clarify the message of how PAM can be used. So it can be used to verify their compliance with the specified quality expectations. And that can be used in multiple ways. For example, optimize service delivery or account for obviously operator to subscriber interaction. Next slide. There was one metric that we missed, so we added packets since last violated packet. Oh, yeah, next slide. And the terminology. So if you recall, in the first version, we were not yet decided whether it referred to the metrics as errored, time intervals, and or violated. So we discussed, and comments from Matt helped us to settle on a violated term. So now everything is referred to as violated intervals, severely violated intervals, or violation-free interval. Next slide. So as you see, so this item can be taken out. There is some more work that we will be doing in working with this document, and still we have some plans for the future, and we'll appreciate your comments, suggestion, and please think about joining the work. There are a lot of work to be done. Next slide, please. So again, we think that since we merged this work and addressed the comments from Ned, the work matured enough that we appreciate your consideration for the working group adoption. Any questions? I don't see anybody on the queue. No. Okay, then thank you.
Thank you very much. That was our last presentation. We made it. Any closing remarks?
Yeah, no, thank you for a good meeting. Thanks for getting through that agenda. I think we had some good discussion here, some good follow-ups, and please, continue those discussions on the list and in the GitHub repos for the documents where that's appropriate. And yeah, we'll see you next time. And have a good and safe travel home, everyone.
Hmm?
7 minutes, man.
Whoa.
Now what do we do? I shared. I'm okay with listening to this session because except for our technical glitch in the middle.
Yeah. Well, otherwise, yeah. And I mean, we're still ahead of time, so.
I think it was good we didn't have another talk.
Yeah.
Like I was comfortable with how we ran this.
Okay, so I could continue with the next step. Oh, that's actually the next step. We have the request for early allocation.
For which one? Like there was already.
It's the.
We asked him or we asked Diana?
No, we asked him. I checked the process.
So we just went to CCM. So yeah, so you chairs email Diana, you CC me, and I say I mean, assuming you guys think it's fine, I go thinking about it. So, well, if people who are debating now, what are the options? Should we now all agree? Yeah. Yeah, okay. Yeah, it took us a while to get there, but now we got there. Yeah, okay. Then yeah. Send it back to Robert. Well done, but you and I are all done. Yeah. It was good. The weekend. Do I understand David had probably the Chrome pizza on this one service was it cockpit? Well, he was. I want to push back on this. Essentially, we're not going to get rid of it. And all the problems he raised were all like implementation. Yeah, he just wants to wait. He wants to wait. But I think is like. Some good trip. What's the point? You already have uses for you is an entry base. It's more like once you have like D4 or D6. For the existing use case that point to use free, but it won't be user. Okay. And then you define this other thing, people move to it, and then the moment you want to define so is alt service this or is it actually kept the legacy use cases? I mean, because we could just like give whatever the old service is, and then the this is like much lower than what the old RFC, right? So that's just documented. You can't tell. Oh, good. Good back. Good catch. Yeah, that was good. You covered it.